This is Group 1B, covering culvert failure during flooding, with Christopher Hall, Zachary Merritt, and Hunter Zielinski. A culvert is a tunnel structure embedded under a roadway or railways to provide cross drainage or convey water to the other side of the embankment. Common usages of culverts include cross drains and passing water under a road at natural drainage and stream crossings, in floodways to enable low-intensity floodwaters to be discharged without any overtopping, in areas where construction of bridges is not viable due to cost versus benefit. They're critical for preventing flooding of communities during normal and extreme weather conditions, as well as being integral to proper road and highway maintenance. General design considerations for culverts include the size of the culvert, depending on the necessary flow rate based on volume and velocity of water passing through the culvert with respect to time, the material of the culvert for corrosion resistance, as well as the soil used in the culvert system. The surrounding soil is needed to create stability of the system, and metal culverts will deform under their own weight without lateral support from the soil. More design considerations include the suitability of excavated soil for reuse as backfill, which reduces environmental impacts since you're essentially recycling excavated material. Culvert failure types include flooding, which is excessive backup on the upstream end, cave-in, which is the inability of the pipe to carry water, settlement, which is the road sinking over the path of the pipe, the head wall is beginning to move away from the existing pipe, the backfill material around the pipe at the downstream end is beginning to unravel and wash out. Under normal conditions, the culvert is able to handle the flow and is not experiencing any failure mechanisms. In this demonstration, we are simulating an overtopping failure mechanic by totally blocking the culvert and eliminating outflow, causing water to pond on the upstream end and overtop the embankment structure, causing erosion across the entire system. During severe rainfall events, debris can become lodged in the culvert and cause reduced outflow or even complete blockage, resulting in water ponding on the inlet side of the embankment, leading to overtopping conditions.
Overtopping failure causes severe damage upstream and downstream of the culvert. It can also block roadways and evacuation routes. If vehicles or pedestrians are on the roadway during an overtopping event, they can be swept away, leading to severe injury or even death.
This demonstration shows high velocity flow coming through the culvert, which causes erosion at the downstream end. Granular soils such as sand or gravel are much easier to erode than a clayey soil. However, they are necessary for the structural integrity of the embankment system and the support of the culvert pipe itself. They have a high hydraulic conductivity, which helps to allow water flow through the embankment and reduce potential ponding. Soil classification is also necessary to identify the material needed for the construction of the embankment.
This demonstration shows a complete washout caused by a high velocity flow underneath the culvert pipe, causing erosion, uplift of the culvert, and finally, catastrophic failure. This real-world example exhibits the catastrophic failure that we emulated in the demonstration.
In order to prevent catastrophic failures like this, proper soil testing such as Adelberg limits, grain size distribution, and permeability tests are needed to ensure surrounding soil is well graded, has high permeability, and is densely compacted soil to allow drainage around the culvert without erosion while providing structural support. Embankment design properties must include a cohesive soil with a friction angle that is neither too high nor too low to ensure lateral support against shearing.